basically, you're missing opportunity and missing risk. But it's getting worse, and here's why. As computers are getting faster, organizations are actually getting dumber. The amount of information that's arriving is showing up on this curve, and the ability of organizations to make sense of it has been flattening out. If you can make sense of 7% of what your organization can know today, tomorrow it's 4%. The next day it's 1%. We did some work for a large retailer, and we found that 2 out of every 1,000 people they were hiring had already been arrested for stealing from them at the same store. This is amnesia. And if you're trying to solve today's problems today, you've seen nothing yet. Look what Eric Schmidt said about a year ago. Every 2 days we now create as much information as we did from the dawn of civilization until 2003. Now when I drew this picture here, and I made this little green line flatten out, why is it flattening out? I did a blog post about this called Algorithms at Dead End. You can't squeeze knowledge out of a pixel. This is a piece of data. This person is just enrolled in your newsletter. All you know is this email address. I would argue you could use an infinite amount of compute, time, and energy. And what's your ability to know whether this is something you should sell or shoot with a laser from space? So when I say context, what do I mean? I mean better understanding something by looking at the things around it. When you see the word bat in a sentence, you look at the words around it to know what kind of bat it is. So when I think of information in context, it looks like this. So when this piece of data arrives, now I would argue you could use an original issue 1983 IBM PC and make a better prediction about what to do about this than infinite supercompute staring at a yellow puzzle piece. It turns out this puzzle metaphor holds up so well. I watch the way people put puzzles together today, and it improves my algorithms. I want you to picture with me for a moment a giant pile of puzzle pieces in the room here. Different colors, different sizes, different shapes. You don't have any covers of the box. There's pieces that are duplicates. There's pieces that are missing. Some of the pieces are just poor quality. Some of the pieces are professionally fabricated lies. Until you take that data to the table and see how it relates, you don't know what you have. So I went and bought a puzzle. I bought this puzzle and I hid 10% of the pieces. Then I bought this puzzle and hid a third of them. Then I bought this puzzle and hid half. And then because I have a dark side, I bought a copy of the first puzzle. And I took 10% of those pieces. And then I bought this puzzle and took just 6. I made a pile of these at my girlfriend's house on her table. My girlfriend sees this as her son and the 3 cousins. You know what I see? 4 parallel processing pipelines. This is the first piece of data that found each other. More data was finding more data here. Here I can see the duplicate. I'm jumping up and down, I'm all excited, it's right there. The kids don't even know this is possible until they find this piece right here. And they look at me and go, oh. They made their own duplicate cube. I've told them nothing. But the puzzle began to take form. What happened? At 6:40 they started. 22 minutes later they said, here, there's a duplicate. Then they said, I think some pieces are missing. 37 minutes in it says, looks like a bunch of hillbillies on a porch. When I talk about this overseas and I'm trying to explain hillbillies, I say that they live in the hills, they make their own alcohol, they have no teeth, and their family tree goes straight down. But that's not important right now. A few minutes later, they say it's hillbillies playing guitar, sitting on a porch near a barber sign and a banjo. Now look at this picture here. Under the white bowl of the barber sign, underneath that is the guitar and then the banjo. This is the puzzle that only had 50% of the observational space. The idea that they're making this kind of quality prediction with only 50% of the observational space, I think is really interesting. 47 minutes in, they realized the sky and grass were not that interesting as features, so they wanted to take them off the table. 2 hours in, the oldest, the 17-year-old female, says, let's switch sides and see if we can make sense of this from different perspectives. I'm thinking, genius. 2 hours and 10 minutes, wait, there's 3, no, 4 puzzles. Then, you know, what is it? You think after building 100 systems, you can size the damn table space right. I kid you not. I'm looking at this realizing these puzzles don't fit on this table. 2 hours and 18 minutes in, they said, I think you threw a few random pieces, and I kid you not, a few seconds later, one of the boys looked at me and just said, you are evil. And I gotta tell you, it was really a great day. Here's the sky and the grass they took off the table. Here's the random pieces they noticed. But nonetheless, the picture began to take form. So I want to just explain for a moment the similarities between the two. You get a new piece of data in the enterprise, you make 1 of 3 decisions. You're not sure, it doesn't really relate to anything, so just like a puzzle piece, you leave it by itself. Or it's like the red and white pieces, so you put it near the red and white pieces. Or it actually connects to something. But you only connect things when you're sure. I call this favoring the false negative. When's the last time you put a puzzle together at home and you said, it doesn't really fit, but with some glue and a hammer, I can get this bastard in there? You don't do that. It's just like you don't match two people because they just have the same name. Sometimes new observations reverse earlier assertions. You put two pieces together, but later you realize you shouldn't. In identity systems, you'll think two people are the same, but later you get another piece of data and realize it was a junior and a senior, and you have to take them apart. Sometimes new observations reverse earlier, oh no, I'm on this one, sorry. Some observations produce new discovery. You get a puzzle piece out of the box that only has blatant grass, but it's that one piece that connects two seams that you had no way to recognize. Now here's my favorite part. When you put a puzzle together at home and it's going to be this big, can you put it together on a table that big? No. It puffs out. The most expensive piece is when the puzzle takes up the most space. But there comes a tipping point where you get the edges and the chunks start to fall in, and suddenly the speed with which you place the pieces down is increasing, and the accuracy is increasing at the same time. I saw this for the first time in 2006, where a database with 5 billion rows had one performance characteristic, and when it got to 8 billion rows, it was faster and getting more accurate. I think that is profound. So I call this big data new physics. Three things happen. You get the right amount of big data together, and you can put it in context. You get lower false positives and lower false negatives. That means higher quality predictions. It turns out that bad data is good. You want the spelling errors. You want the transpositions. Here's a place you've seen this. When you search Google and it says, "Did you mean this?" It's not a dictionary. It's remembering people to errors. If you didn't remember the errors, it wouldn't be so smart. And the third and final one is why you get more data, you need less compute. This is, to me, amazing. When I try to explain this to my friends, I'm like, why is it when you put a puzzle together at home, the last few pieces aren't as easy as the first few? You have more data in front of you than ever before. So now I'm going to tell you a quick story about how you get to enterprise intelligence from here to there. So I want to first talk about sense and respond. In the center is what you know. This is what you've already observed. And now you have new observations, whether it's transactional data, whether it's social data, whether it's people are inputting stuff because the human is the sensor. Watch this. Here's a piece of data. Boom. I call that data finds data. I do that myself, by the way. Now, only after the puzzle piece lands do you look at the puzzle pieces around it and then say, does this matter or not? And sometimes you're going to want to do something about it right then. We're talking sub 200 milliseconds, fast enough to do something about it, to put an ad on the page, or to do something about a cyber transaction. Here comes another piece of data. Watch this. Boom. Lands here. Now you decide what you want to do with it. You want to give it to a human. I call this data finds data, relevance finds you. So on this side of the equation, now is explore and reflect. And one of the things you want to be able to do is deeply reflect. This is no different than when you go home at the end of the day and you're sitting on the couch. You're not being pounded with any new data. You're only contemplating with what you know, or I say drawing value from the data that you've curated. So there you are, you're sitting on the couch at home, and you go, oh man, at the office, Billy has a crush on Susie. You're doing deep reflection. This is where you discover patterns. And sometimes when you discover patterns, you can say, I'm going to keep my eye out for that. And in this case, you might say, if I see Susie getting flowers in the office next week, even as the flowers are heading towards her, I'm calling Billy, and I'm going to tell him he's a dog. So what kinds of things make this possible? Well, infosphere stream, if you're trying to get transactions off-center, off source systems, off the sensors, super fast, infosphere streams is an example of that. Deep reflection. Netezza or Hadoop product big insights. When I think about things for humans, I'm thinking about Cognos or our latest acquisition called I2. Getting relevance to sensors, back to sensors or back to other systems, you might use a rules engine like iLog. And then you might take this data and also put it in your information management systems where you're managing and reporting. And this would be examples of that, our content management, case management, document, and data warehousing products. Now, what about this in the center where the data finds the data? Do you think it's white space? For sure not. This is why IBM bought my company. They bought my company for this one piece of technology they built for the casinos. It was called LoRa. Now it's called Identity Insight. And then, while that today is scaling, we have customers with 100 terabytes of solid state. Over the last 3 years, though, I've been building a new next generation engine. It's been almost entirely secret until about 6 months ago. Internally, my code name for this is G2. And now in CA trials with it around a product that's not commercially available yet. It's only in alpha. It's called sense making. The idea is sub-second, 200 millisecond sense respond. So you can do something about transactions while they're happening. It's designed for NoSQL, row store, grid compute, so you can scale to petabyte scale deployments. And the same little piece of code that we're building called G2 is in the lab right now getting integrated in SPSS. And in SPSS Modeler Premium, everyone will have access to this. And the roadmap from there up to really large petascale sense-making engines is going to be same schema, same config. I am super excited about it. I don't think anybody else is working this. It's why I'm at IBM, and it's really fun. Okay, boom. Closing thoughts. The most competitive organizations are going to be the ones that can make sense of what they're observing, fast enough to do something about it while they're still observing. You want to wish this on the enemy. This is the way forward. It's getting you information in context. I think of this as context accumulation. I'm a slow motion tweeter, I'm a slow motion blogger. I answer every email I get. If you all email me, it'll take me a while to answer you, but I will answer all of you.